If you're the kind of senior engineer, architect, or technical leader who people look to for what's next, QCon London is probably on your radar. Join us in London from March 16th to the 19th, where we go deep on the topics that matter, like the architectures you've always wondered about, engineering productivity, and applying AI in the real world. This isn't about trends for their own sake. It's about getting practical insights from senior practitioners to help you make smarter calls on where to invest your time in tech. With software changing fast, QCon London is a conference that helps you lead the change. Learn more at qconlondon.com.
Welcome everyone. We are starting second podcast in our series of Next Generation Architecture Playbook, and it's about insights and patterns for the AI era. Earlier we did episode 1 of this with Grady Booch, where we discussed the principled view of that what's changing and what remains unchanged, what is hyped and what is actually naturally coming with the AI changes. We also spoke about that what is the difference between the design and the architecture and what teams are focusing and what they might be missing. And the beautiful part was that Grady touched upon the third golden age which we are living into for the software engineering and the architecture. So if you have not listened to that podcast, I would highly recommend go back and listen, though it's not in any particular order, but that will also give you a lot of view. With that said, I'm happy to start with our second episode, which is all about evolving architectures. That what is evolving in this AI era about the architectures and how do we go about it? Some advice, practical advice on it, that how do we really go about designing it from our experiences. And to touch upon that and discuss it in detail, we have our guest today, Jesper Logren. Am I pronouncing your name right, Jesper?
Perfect, thank you.
Thank you. And Jesper is joining us from Australia, and late evening for you. Thanks for making it happen. A little bit about Jesper, and then I would ask you to add all the missing details which I might miss. Jesper is Enterprise Architect Lead with DXC Technologies. He's been teaching us about Enterprise Architect Frameworks. He is also an author of Enterprise Architect 4.0 Framework. And recently he has written a book which I really love by the name Design or Be Designed. So with that great background, what you have, Jesper, tell us a bit more about you and what is your thinking these days. What do you want to tell us?
Yeah, thank you for that introduction. I think the only thing I would like to add is like the last 2 years, I have been almost obsessive about generative AI and how that is affecting businesses and people and processes and entire workplace. And I have been lucky in the sense I've been able to manifest a role within DXC where I am 100% focused on generative AI and building up frameworks and models, and then being able to go in and talk to customers about it, running proof of concepts and running experiments, etc., and actually see in real life how these things work. Because of this new world that we're going into, this new Gen AI fueled world, is very different. There are a number of fundamentals in this world that is very different from the world that we are coming from. And again, I find it very interesting, and I'm very lucky that I get to spend all of my time in this place, partly experimenting, but also designing and architecting and testing things, what work and what doesn't work. And yeah, it's very exciting times.
So we are into generative AI. Do we need generative architectures? While you said we are experimenting, we are designing and architecting. But the change here is the pace. We always used to do it, but in every era we do something and we leave behind something and move on to the next thing. So that brings a consecutive momentum of lacunas, what we are leaving behind. But with this space, it's insane these days what is happening in the industry. However, most of the time I see it's around tools and not really around the system thinking and systems, how they are evolving. So tell us from your experience, what you're going through these days, that do we need generative architectures? What is the problem space really looks like from your perspective?
I think the short answer is absolutely we do. I would like to take a small detour because I think that sometimes the differences are not really appreciated. So I'm just going to use an analogy. So let's say 100 years ago, we had a piece of paper, I'm a salesperson, and I take a sales order, I'm going to write it down on a piece of paper. We get into year, let's say 2000 or 2010, and then we are starting automating all of these pieces of paper. So now it's a digital copy of the paper. And we could choose to digitize the entire workflow end to end and make the completely digital process, or we can choose to only digitize part of it. So we have all of these shapes of gray. We can automate a lot, or we can automate little, we can introduce a lot of technical debt, or we can introduce very little debt. It's a choice. We don't have that choice in AI, because if we're introducing technical debt into AI, into generative AI, it's going to drift and it's going to hallucinate. So I think our mindset has to shift. We have to think about it differently. And that means that also the architecture has to change. And of course, the real change here that is driving all of this change is this word autonomy. Because if we don't have autonomy, we just have the robotic process automation. And we have done that for a while. So, I mean, there are no secrets. It's real autonomy. How do we handle autonomy? Because what happens is that when we're turning on the autonomy tap, we're giving the agents free will, it is going to play up. It is going to do things that we don't expect it to do. We're calling emergent behaviour. It will absolutely happen. If we are putting a number of these agents together and we are connecting them into a system of agents and they're autonomous, we're going to get emergent on steroids. These are new situations that we haven't really faced in the past. We're used to governance where we know exactly what can go wrong because everything is procedural, everything is logic driven. It's a list of 20 things, and we know that if something goes wrong, it's one of these 20 things. But when we talk emergence, we can't predict exactly what's going to go wrong. So our entire thinking around architecture and design and guardrails and governance, everything has to change in order to be able to manage and control this new thing that we call autonomy.
So with that, we are acknowledging that yes, things are changing fast. We cannot rely with the same rules in the new world. To dig deeper into this architectural space which we are talking about, what are those architectural mistakes? What do you think that people are when they are embedding AI into their existing platforms? What is wrong there? Are we doing some things good? Are we doing some things wrong? So let's talk about the problem space in terms of bit more concrete that, okay, things are evolving, acknowledged, but what is that mistakes we are doing here?
I would take a step back and I will look at the MIT report that was released about 3 months ago in 2025. Let's talk about 95% of all proof of concepts failing. And we need to understand why they're failing in order to really address that story. And I'm going to put forward a hypothesis that I'm proving in a number of customers, and they're starting to be more and more writing about it. And it is mindset shift again, that in the past, if we are building a system, if we are architecting a system, or we are designing a system, we are really in this mindset that we're calling procedural logic, that we are determining the workflow, we're building the workflow. Start with this, and then you have an evaluation. If it's A, you do that. If it's B, you do that. And you have this entire sequence of events. So it is determined already. So we have that on one side. And then on the other side, we have autonomy that is free will. This is like oil and water. They don't really belong. This one wants to do its own stuff. And here we are telling it, you have to do it in this way. It will be an incredibly expensive way of employing AI to try to put generative AI into procedural construct. We're getting all of the cost and we're getting none of the benefits. So that is not the answer. And we're coming back to the mindset shift again. It's not about controlling the logic or the logic at runtime. It's real about understanding the boundary. So it's almost like looking at it like a genie in a bottle, and a genie in a bottle, that's a naughty AI agent. And that naughty AI agent wants to get out at any cost so it can play up. We have to make sure that the boundary that we are putting around the agent is tight. that all of the seams, all of the holes, all of the interfaces into this boundary, that we really understand what they are and we really understand how to control them. Once we do that, then we can say to the AI, I'm not going to tell you what to do. You're really smart already. Some of the AIs now that we're working on, they have an IQ of 140. That's higher than me. The AI is much smarter than me. I'm not going to tell it what to do. I'm going to tell it more about what it can't do, and I'm going to tell it what I want it to achieve. So I'm going to give it a goal, for example, and that's very important when you talk about AI. You want to give it a goal that knows what to achieve. And I have identified 7 things that are defining the boundary of an agent. And if you're defining these 7 things, you can have a fairly high confidence that the agent is going to be contained within that boundary. And of course, the real problem of the agent is when you get multiple agents together and they are sort of getting emergent behaviour together. That's when you really need that boundary. The more agents you have, the more control of that boundary you need to have.
Yeah.
And that's the first step. If we don't understand what makes a system scale, and that is, I think that's what an architect brings to the table. We are the people that understand scale. Everyone else, they just want to take the bits and pieces and start hammering them together and then worry about what they're building a little bit later on. Architects, we are the opposite. We build the foundations. They were building foundations because we want to scale. And when it comes to AI, that is such a different foundation. It looks nothing like the foundation we are coming from. As I said, I have the way that I'm defining this is I talk about seven seams, and they actually form part of the agentic architecture where you need to define the goals, you need to define the authority and the decision, like the policy, etc.
Before we go into the 7 practices and those goals you're talking about, so let me express from my understanding the important points which you have touched upon. You said we are trying to do some retrofitting with maybe where we should have intentional design. You said we are trying to handle procedural with non-determinism. So we are trying to merge and marry these things. But other aspect which or the problem side of which I want to delve into, because yes, that's one major part of it where the architecture and design is sometimes totally skipped and sometimes looked into very shallow way. But the important thing here also is that speed of innovation with keeping the reliability and governance in place, because we know the reliability and governance is not as speed up as the speed of innovation has become. Can you touch upon this aspect as well? Because one is the design piece of it, which we have already touched upon. The second part is the governance, the innovation and the speed with which business wants to accelerate.
Yeah. The answer is that they're one and the same. And I think the best way of explaining why I'm sort of saying such a contradictory thing perhaps is that I love the analogy of a merry-go-round. It is spinning around, we're sitting on a horse, it's going up and down. And it starts spinning faster. And we have to hold on a bit more, right? And then it starts going faster again, and we can't hold on anymore. It spins too fast. Either we let go and we fly off, or we move into the center. So we move into the center, holding on to another horse, and we are fine, but it spins faster again. So we're moving into the center further and further. And I see this is really what's happening with agentic AI or Gen AI. Is that things that were a strategy document, that was an architecture on a diagram, we have a design, a BPMN here, we have a governance document here. They don't sit on the outside anymore. They can't sit on the outside of this world. They're coming together and they're fusing. So for example, to answer the question is that you must design governance into the agent or into the system at the same time. They are not separate. You actually do them at the same time. So it's not like you're innovating and then you're catching up. That will never work, because you're always going to have a mismatch. You can't have mismatch in these systems. They're going to drift into horrible things. So they actually need to be joined at the hips when you're designing the agent. So you actually need to build the governance into the agent when you design it.
That acknowledges, and I love the analogy which you have used. either control it from outside, or you get spinned, right, with the moving thing. So
exactly right.
yeah, but now let's delve into the guardrails which you're talking about. So what are those guardrails, and would those be evolving? Let's, if you can take some examples along with the 7 key framework which you want to touch upon, but can that evolve too? Because again, we cannot be doing the mistake of being rigid with our design. So I call it that designs are drifting all the time.
Absolutely.
I have touched in my book and some techniques which I have laid out there. But when designs are drifting, our mindset needs to change. It's one-time activity. While I talk to various people, it's like we have done the design in the beginning. We are done. We are not done. It's changing with every configuration change in cloud, with every configuration change which a developer is changing, or maybe AI is changing on its own and not even telling you. So let's talk now about those guardrails. What do you think those things should be with this changing world? And how do we make them evolvable?
And they're absolutely evolving. And the way that I'm looking at it is I'm using the maturity levels 1 to 5. And I've invented a 6th one that we can talk about if you're interested. But let's say there are 5. And each of these maturity levels, and it's useful to go through them. So the first one, that is ad hoc. That is CMMM level 1, typically ad hoc. We get benefits, but we can't measure them. So that is when you're AI, that's when you have an AI assistant. You're enabling Copilot for everyone in the organization. You're going to get benefits, but it's hard to measure them. And then level 2, that is things are being repeatable. And that's where I put in the AI agent. You can repeat the business process. You can have a policy agent, an deployment onboarding agent. It's a singular agent with a singular purpose. So far, we don't need to change that much. What we have today can handle that. I mean, we are deploying these kind of simple agent systems, and they work okay. They're expensive to maintain because they're brittle, but they work. It is when we get into level 3, and this is when we have the multi-agent systems, and we have some level of autonomy. I'm not even talking about 4 and 5, it's so speculative. But level 3, we have multi-agent systems. This requires a new operating model. It requires a new design language. It requires a completely new architecture, a completely new governance approach. And it's a really big step. That's why I think that we need a step in between. So putting in step 2.5, that's a multi-agent system, but it is without the autonomy. And when you're looking at the guardrails, they look different as you're moving in between the maturity levels. So for example, one guardrail that's very important and not quite understood, so it's a good one to pick. It is authority and the decision rights. If we are going to put any kind of autonomy in, and we're going to give it agency, that we are going to allow it to make the decisions on our behalf, we need to be crystal clear on what kind of decisions it can make. I mean, it's common sense, but it is something that's been left far too late. So that's a really important guardrail, that you always understand what exactly can the agent decide and what can't it decide. And when you're moving, for example, from a maturity level 2 into level 2.5, there's quite a delta. And then when you're moving from 2.5 into 3, and you talk about autonomy, there's a quite big delta again. So the guardrails are changing, and also because you need to look for different things. When you turn on the autonomy, suddenly the risk picture is much more complex. It's much higher. So again, your guardrails have to reflect that, and you need to design that into the agent again from the beginning to make sure that you can scale both what the agent does, but you can also scale the governance. Again, I'm coming back to this thing. They have to be joined at the hips. It's really important.
Yeah, while you're bringing agents into the picture, I'm more worried because everything is not a agentic problem, right? While we'll talk about that later, and we have a dedicated time for that separately as an episode as well. But I like the framework which you're saying, where organizations can assess themselves. Most of the organizations in the initial level 2s, which you said, ad hoc and the other one. But what are those guardrails beyond the policy documents, or maybe very high level principles we are giving people that have the least privilege? Let's talk about those. I mean, when let's say I'm putting my new AI system, which is driven by LLMs, which is driven by Gen AI, and maybe let's say it has some agentic components as well. Now I'm marrying and merging this with my existing system, which is procedural, microservices based.
Yeah.
What is one or two those guardrails which you're talking about in terms of what you said?
Okay, there's actually guardrail for this specifically. So we have 7 of them, or I have defined 7 of them. There are obviously other ways of approaching it. I really found one way of doing it. So one of my guardrails is scope. And the scope is specifically about understanding what your interaction points, what your contact with the other non-agentic world is. So let's say that you're interfacing into an ERP or a CRM or any kind of external system, whatever shape and form. You actually have a guardrail specifically for external systems. So that's how you manage that. Also, to give another flavor of these guardrails, I mentioned one is goals. This one is actually really important, and actually, in a sense, perhaps one of the harder ones. Imagine if you have an agentic system, and here you have agent 1, and this is the profit maximization agent. And then you have agent 2, and this is the margin maximization agent. And then you have a third agent. So we're going to introduce a few more. That's a warehouse. Let's say that you're putting all of these agents together. They just say, hey, go for it. That would be very, very dangerous. They have their own goals, and they're going to pursue their own goals, but you have no idea what the emergence is going to be. So again, one of the very important things in the boundary, one of the governance pillar, is this ability to be able to define a goal in an intelligent way to an LLM. So if you have 3 goals here, you need to provide some kind of guidance to the LLM how to view it. And it could be, for example, and again, we're touching on another guardrail now, that's policy. It could be a policy that says that you must never, ever go below 10% profit margin. So that might be a constraint that is built into one of the agents. So that is how you start to put boundaries around them and what they can't do, and that is policy is the main instrument that we do that. And then we're also balancing the goals and saying that this goal is going to be more important than that goal under these circumstances. So we talked about procedural logic. It doesn't disappear. We are pulling it out of the core. We are pulling it out of the code, and we are putting it in a boundary instead. And we are telling the LLM, okay, you figure out the code as long as you are following these guardrails.
Makes perfect sense, Despa. I think what you're telling us to do is, and more organizations to evolve, and even the people who are working behind the scenes to come up with more of these emergent behaviors where the goals are separate or distinct, and then still system has to work. So again, things come is that we need more system thinking than ever before.
Absolutely. Can I give an example?
Sure, please.
Okay, so this is how it plays out in real life. So this is a little bit wild, but I'm doing it anyway because I think that we need to push the boundaries, and it works. And it's completely new design process. So I'm used to the old rule, and I've had so many workshops. You get a team of people, you have the whiteboard, you can do service, the blueprint or customer experience, design or BPM and diagram, and you draw and you have sticky notes, da-di-da-di-da. I'm running design workshops radically different today. So recently I did one for a listed company in Australia, and I captured all of the information around the boundaries for as much as possible. With the goals, I understood about authority, delegation of authority, for example, a lot of the policies. We understood the interfaces into other systems, etc. So we could define the boundary. So I had defined the boundary in an LLM. And then we invited the customer. They flew in for all over the place, and we sat in the room. There were 2 IT people from the customer. I think there were 4 people from the business, the senior people in different areas of the business, and a couple of people from DXC technology. And I said, we're going to design your future call center process now end to end. I put in everything into the LLM. It understands your business. It understands the boundaries. We are now going to say, instead of going up to the whiteboard and start drawing, we can't design a process for AI better than AI can design it itself. We need to let AI design what we do. And that's what we did. So the first prompt, it was a big screen instead of a whiteboard, so everyone could see my typing, which is terrible. But then I put in a prompt. Based on everything that you know about company X, I want you to develop an end-to-end process that is taking everything into account. Hit enter. And it goes away and it comes up with an agentic design of about 27 agents. I've also written a program that I can feed it into so I can get it graphically represented. And then rather than go in and try to understand the process, because some of it was common sense, other things not so much, I'm taking a very, very different approach. We want to test the boundaries. Everything is about the boundaries. So these business experts that I had invited, they were people that really understood their business and everything that could go wrong. They were experts in the edge cases. And that is how you validate the system. It's one of the best ways. You start through every edge case at it, and you try to break it. I made it a competition, a bag of lollies for anyone that can break the AI. And actually one person could. They found an area where it had considered that it needs to apply national policies depending on the country team when it comes to bioprotection and things like that. So we ended up with 33 agents instead. But with LLM designed the entire system inside the boundaries because we had defined the boundaries. And then when we had done that design, we took a part of that and we automated the coding and we actually built the pilot. It's a new way of thinking. It's a new way of operating. It is insanely fast.
Absolutely. Absolutely. I love that this organization you worked with is spending so much of time doing it. I wish everyone does that because that's extremely missing in the whole pace of AI. And while we were touching about system thinking, I also want to throw one example which I absolutely loved from Dr. Werner Vogel when he gave his last speech, this reinvent. He mentioned that there was a forest from which, the wolves are removed because those are very aggressive animals to be and killing everyone else and doing the damages and all seemed logical. Everybody supported it, and wolves were removed from the forest. And within a decade of removing them, everything started to degrade. Water problems, forest problems, greenery problems, and even certain breeds were dying. And that made them to look back that where we went wrong. Then we went back into that removal of wool was the bad decision they took, and they had to bring it back, put it together again, and then within few years it started evolving. So while everything might seem logical when people are putting their AI strategy decks, most of them have these days, system design is missing. That how this is working today, how will it work with the new components, and how will it evolve? In this whole picture, if we now move towards the guardrails and the safety aspect of it, what are those content filters? What are those fallback logics? And what is your advice in that area?
I'm coming back to these 7 themes again in the boundary. I think the way that I understand agentic and generative AI and how it's going to affect architecture, to me, that sort of almost like sits in the middle and it informs all of the conversations. So, for example, in terms of safety, one very obvious one is risk. So one of the dimensions, one of the 7 is risk. And that is really, again, understanding the risk within an agent, understanding the risk within the system. and understanding ways of, firstly, how they happen. I mean, emergent behavior, even if we are defining the boundary, how do we actually define the emergent behavior? What are we actually looking for if we don't really understand it? And that is part of the risk, etc. That's part of the safety in the system itself, because we need to have some kind of understanding of it in order to trust it. And I have some ideas about what those things are. I think that we can sort of work out the minimum viable starting point, that we can start, that we can learn, etc. over time. So I think the risk is very important about the safety. I'm looking at safety a little bit different probably from where you're coming from. I think safety, for example, also sits in one of these dimensions of the boundary, one of the 7, and that is semantics. Ontology and semantics. You cannot build any multi-agent systems unless you have more ontology and semantics. And that's part of the governance as well, because if you have an agent here and you have an agent here, if they're operating independently, fine, but I don't think we really care too much. If we're stitching 5 of them together, where they're making decisions and they all have a different context, that's not going to work at all. They're going to drift and hallucinate immediately. So we need to give, in multi-agent systems, we have to give the agents the right context at the right time so you can make the right decision. That is critically important. And that is what the semantic dimension of the boundary does, in making sure that all of the agents have the same understanding. That if we're talking about, for example, done in the context of the customer order, every agent in the system, including humans in the loop, they know exactly what done means. It doesn't mean this or that. It means exactly this, and everyone is interpreting it at the same time. That's another way of enforcing safety, that we always are using the same language to communicate. And another way of looking at safety, coming back to the boundaries again, is evidence. It is sort of an output of policy, perhaps, but it's really about how do we know that something in the system is true? How do we prove anything? How do we retain the record so we can go back and look at something? Yeah, it was true at this point in time. I mean, that is also about making the system safe. So there are a lot of these boundary things around, and then we can build other things into here. We can talk about fairness and ethics and morals and all of these kind of things, which is all about how we're controlling the model and making sure that the models are doing the right thing, etc. But I think the question about safety is so broad, and it actually touches everything. I think if you don't trust one part of this system, it's going to be hard. It's going to be hard to trust the whole system.
A lot of things you've said around it, and semantics and risks and the boundaries of the system, and looks like you're quite already deep into the multi-agentic system architectures which you are thinking and writing about. I want to bring you back thinking atomic, because while we are talking about organizational risk, the user trust, the in between everything, things start small, right? When a developer is writing,
Yeah.
maybe vibe coding or spec coding or whatever, spec driven development, and then we are pushing this code to production at a pace. And now that person is not in position to think that user level of safety, maybe not even knowing that user level of safety and the whole ecosystem. Where do we start atomically, or the unit level, when I'm defining my function, and how do I think as a developer that what will be the emergent behavior of this? What would be small things out there which then builds it to the semantics which actually makes perfect sense and connects the dot fully?
I will do what I did. So when I started this, I'm not a developer, although I'm a reasonable vibe coder. So when I started 18 months, 2 years ago, and it was ChatGPT 3.5 back then, I realized immediately this was going to be really good. Here we have automated cognition. This is going to have to make a difference. And I just understood immediately that for all of this to work, it is not about having a bot here and there. We're going to have to be able to connect them. And in my mind, it makes no sense unless we're actually looking at them in terms of system. It's not about trading an agent here and there. And I think that as a developer, we will have to set our sight much, much higher than that. We need to set the sight on the system and understand the system. And then we're coming back to some of the things here that we have talked about. But I think that a lot of these things here, they sound complex and they sound different. They're actually not that complex. I have just come back from a piece of consulting with the government department that is redeveloping all of that horribly complex core systems. And I'm looking at that, I'm thinking, technical debt, holy, and I'm not going to say the F word, but holy F. And I'm thinking, this is so complex that you can't fix it. It's unfixable. How do you untangle all of that spaghetti? You can't. So we are facing incredible complexity already. So the world that I'm painting, it's not that complex. It's just really, really different. It's a mindset thing. It's a harder thing. If you go in and you build a multi-agent system, and let's say that you use a framework like Crew AI or Magenta, it really doesn't matter which one you're using. You can build an agentic system using procedural logic, or you can build an agentic system using the principle here that we are talking about. It's not that one is more complex than the other. It's not that one is more harder than the other. We just have to think differently. The difference is that one of the system has infinite scalability and has all of the governance built in through these 7 layers before you even start designing your agents. So I think for my recommendation for developer that is working in code and working in the traditional systems, the development lifecycle, get off it. Honestly, get off it. It's a race to the bottom today. The power of the technology and the tools is changing things very, very fast anyway. I would just start investing time in learning it, experimenting. Take some of the things here that we're talking about, perhaps even buying my book, Agentic System Design, which explains how this works. You can take that book and the principle, then you can build an agentic system along the lines of what we are talking about. That is what I would do. I would not continue what I'm doing and try to do it better, faster. I will not race in the same race. I would go into another race.
Yeah, definitely. Maybe what I think is that that's where organizations are doing all the AI access and the tools to people at all levels, but they're not giving the AI ability, which is needed at all levels from top to bottom. So, well said there. Let's talk about some trade-offs in this space.
Yes.
Is explainability, evolvability, and I see it as like pace versus stability
Yeah.
also is a thing now. What are the new trade-offs do you think are very important to keep in mind now?
Yeah. I scare people. When I talk to executives, I scare them on purpose and I say that you're used to a world with technical debt. In agentic AI, that can't be technical debt. That is not strictly speaking true. I'm exaggerating when I say that. But I think the conversation is really about how much technical debt can we afford. Because when you're talking about an agentic system, even if it's not autonomous, you're still going to have emergence. So when you have all of these agents connected doing things together, something's going to happen that they can't predict. This question is how much, that how significant is it? So in terms of trade-offs, it really comes back to, I think, how much technical debt you can stomach. When you allow technical debt into the boundary, you know that something is not going to work properly. Something is going to drift. It will always drift unless you lock it down. So the question is, how much drift are you willing to accept? And it could be that there are certain systems that are not involved in, let's say, really critical decisions, like, for example, the payment system or trading systems that are dealing with very, very important things. That could be, for example, it could be policy system around travel. it could be that we are happy to accept a little bit of drift in these agents, because at the end of the day, if the agent is getting it a little bit wrong or the workflows are working perfectly, well, it might not matter too much. So I think the trade-off is really going to be about how much are we willing to let agents drift, hallucinate, lose insights into the reasoning, and it really comes back to the business problem they're solving. So obviously, the more important the business problem is, the less drift, then the more governance, etc. we need. So I think that it is a bit tricky.
Agreed. That's the layering what we need to do, maybe, to really get to overcome those trade-offs which we have spoken about. Now let's move on to the responsibility boundary. We have created a lot of layers in the organizations, from product team to platform team to architects to various other things. In the governance, security usually stands alone, where we say that it has to be all connected. What do you think about the responsibility boundaries around generative AI and agentic systems? Where does it lie? When something goes wrong, when it hallucinates, whom should we blame?
And it's a good and interesting question. And I had to speculate now because I don't think the systems I'm part of, the designing and implementing, have been running long enough to sort of really comprehensively answer that. But having said that, if we go back to architects, because architecture is the most important profession on the planet, right? If we go back to architecture changes quite a lot. And I think that there are going to be certain responsibilities in this entire new operating model that we are sort of implicitly discussing here. And let's start at the top. For example, business architects. They will be responsible for, it's not so much about capabilities and those things and more. They're going to be responsible for the policy. They're going to be responsible for the anatomy of the policy and the structure of the policy. Can these different policy types and these policy instruments, can we capture the essential business rules of the organization using these constructs? And if we can't do, we have to sort of change, etc. So business architects are going to be intimately involved in this sort of interface in between the business and agentic AI. And this is similar with other roles. My hypothesis is that I think the business architect is going to be the most impacted. I think the second one is going to be the data architect, because ultimately data is everything. And it's okay if we have a proof of concept or a pilot, it's small, as we are opening the ecosystem, or we are allowing other data sources coming in. If that data is not high quality, that is, if it doesn't fit the ontological and our semantic layer, then things are not going to work.
Yes, that's a space which needs to evolve further with the boundaries that we have created, and of course the Conway's law, which always comes in the picture here. What about the agentic? Now, I know you are. We have written a lot about it, and even in the whole talk, you've spoken about it. With agentic, are we solving the real problems? Are there any problems because one day I and one architect had very good discussion, and we were saying that while our managements are saying go solve the problem with the agentic AI, what is the problem? I mean, everybody is putting a solution to it, but what is the problem which agentic solves, and what is the problem which is not meant to be solved by agentic AI?
I think the first problem is mindset. I think that if we are going to play in this AI sandpit, we cannot take the old world with us. It's not designed for autonomy. It just breaks. So I think the mindset is really, really important. I mean, perhaps that is all it is. If we understand that we are turning the world upside down and we are letting go of logic, and we're going to replace logic with autonomy, and we're putting in autonomy, well, in order to control that, we're going to have boundaries. If that sinks in deeply, I think that we have solved 75% of our problems. because did you get everything? Once you understand that, did you get the design language? I mean, you had to design your goal, you had to design your authority, your policy, your scope, your risks, semantics, and evidence. It also gives you the governance language. The goals are also providing governance. Authority is also providing governance. I mean, your delegations of authority, for example. In my perhaps very simple mind, just this very concept leads to so many answers to some of these really difficult questions. I mean, brittle systems. If you're trying to build an AI agent and you make it deterministic, it will always be brittle. It's not meant to be deterministic. Generative AI is not meant to be an if-then-else construct. It's not meant to do that. It's not meant to be that. It would always play out. It would always be brittle.
Yeah. While this whole answers will evolve with time, but yeah, you said it right. It's not if and else problem, which most of the teams these days unfortunately start thinking. But that's one correction we can do.
One thing to keep in mind is that we are, of course, in the very beginning. And when we are thinking about the agentic system, we are thinking about frontier models and ChatGPT and Gemini and all of those things. They are very, very expensive to use. So I think that one of the big changes of this is going to be not even using the large, they're all generative AI, but rather using the large language models. We also use the small language models because there are, when you're building these multi-agent systems, for example, this 33 agent system that we designed for this customer, we don't want every one of the 33 agents to go hit a frontier model and start incurring a lot of costs. So it's a question of also understanding the system and understand how to design it and what components to use and what kind of LLM they're going to use in what circumstance. And I think that if we have access to the very low cost, small language models, I think the use case of AI is going to be bigger again. So again, I can't think of any areas where I think immediately we should absolutely not go there.
Yeah, that's a good advice to keep. I would tell people who are listening to this, we are relying so much on Gen AI and LLMs because Llama came out, then so many models came out, and then whole world started drifting towards Gen AI. Is that the only piece of research which we can leverage on?
I'm the wrong person to ask because I think I have an LLM addiction myself. And I think I use it differently. I don't use the LLM to write emails and things like that. I write by an email, so I'm happy doing that. I have my own style. I speak with an accent, I write with an accent. I'm quite happy with that. To me, what the LLMs are really useful for, the way that I use them, is that they're really, really good at helping you connect dots. So I create a lot of thought leadership, for example, around AI. I have a lot of ideas. I create a model. And the best way to validate the model is to take it into the LLM and say, this is what I think. First, you validate it. What do you think? And quite often they come back and tell you it's really, really good. Of course, we know how to write. But then you can do some deep research and you go in, okay, so what exists in other parts of the world, etc. And then how does this relate to other thought leadership I have developed, etc. And when you start attacking something from a number of different angles, it's almost like you see a new ontology. So you have an idea and you see an ontology of your idea expanding. I think that's really cool. And that is when you can just create. I'm a consultant, so this is what I do for a living. And the fact that I have a tool like that at my disposal is sort of increasing my productivity drastically. If you're using it simply to answer questions and if you're surrendering your own thinking, your own free will, your own critical thinking, that's clearly not good. That is really misusing the LLM. You should never. You still have to think.
Yeah. And with that, we are at the end of our conversation. It's long time we have taken. I think one clear takeaway from my end on this discussion is that we definitely need evolutionary systems, evolving system, emergent behaviors, and the new guardrails and the new architectural practices. And one thing which I've started stating to various teams even more now is that architecture is required much more now than ever before.
Absolutely. As a matter of fact, I'm telling people, I'm an enterprise architect. I'm telling people that enterprise architects, they're not optional. No architect is optional. I think the real difference is that technology architects, I think we always need. Solution architects, everyone has them. Data architects, almost everyone has them. It's really the business architects, then the enterprise architect, they are going to become essential. Because the enterprise architect is looking after the entire ecosystem that we are talking about. And the business architect is going to be this critical new business interface between the business and your agent system, all of those translation layers. So I think it's a great time to be an architect. It's a fantastic occupation going into AI. It's going to be super exciting.
Absolutely. Completely agree. In fact, the responsibility increases much more where first architects need to be doing the right job and then bringing our engineers, senior, junior engineers to that level where they start connecting the systems and start thinking in systems that where my work or my vibe coding can impact the organization or the user or the function, and where it couples more where it shouldn't. All these things are important to keep in mind. With that said, it's good segue to end this. Any last thought, Jesper?
I'm just going to say the boundary. Remember the boundary. That's all.
With the boundary, and before that, create that boundary so that you stay in control of things and don't let things control you. All right. So with that said, thank you for joining us, Jesper. It was really a good discussion in terms of thinking. We may not be able to answer all the problems today existing, but we have thrown certain ideas for sure, which are which deserve to be listened to and which needs further work to be done in those areas. So thanks a lot for joining us today.
Thank you so much for having me. Have a great day.